So first thing, I know some of you in the audience are data scientists or have a very strong data science background. Others are more on the leadership side. So I just want to sort of level set. I'm going to be using the terms eval, evaluation, and benchmark and test fairly interchangeably. But in terms of a definition, an eval is a set of tests that can include a particular benchmark, but often is a bit wider than that, a bit broader than that, and can include other assessment methods of testing AI systems such as human feedback review. If you're familiar with cybersecurity, so red teaming and sort of adversarial testing, so pushing the boundaries of guardrails. But then also what I'm going to sort of dive a bit deeper on is domain-specific testing, so industry-specific, your market, your product-specific type testing. So an evaluation is a test. There are different ways we can do a test, and it includes benchmarks, and I'll talk more about that in a moment. Before I do that, what's the actual problem that we're tackling? I've experienced this building AI prototypes. I'm sure you have too. A lot of businesses, it's a common issue, are struggling to validate their AI products, particularly generative AI products, which is what I'm talking about, I'm focused on today. Validate them for their industry-specific use cases. There are some early products out there. However, there have been some quite high-profile issues with, for my industry, aviation, so airline customer chatbots and ticket refunds, buying a car and being able to buy it for $1. There's a validation gap between the lab and getting this stuff out there in a robust way, and having real confidence in the product out there in the market. And part of that is the contextual blindness. So there are a lot of benchmarks out there, public ones, and I'll talk about that in a moment. But the generic ones that often test for things like PhD maths expertise, or physics and chemistry knowledge, or generic problem solving, often miss that sort of critical questions, the critical tests that are relevant for your industry or particular ways that your business operates with your business data. So we've got an implementation hurdle. If you're familiar with technology readiness levels, they run from 1 through 9, starting right in the lab with an idea, number 1, and 9 being in the market, fully robust and maintained and up to date. There's a gap between lab experiments and prototypes and what people share on X and LinkedIn about the amazing things they can do, and actually then the product in the market. So TRL level 6 is a representative test, representative data with a product. So that hurdle, I sort of articulate that as the lab to deployed product, or at least product tested with representative data as being the gap. And then there are some hidden risks as well. So I'm sure everyone on this call has extensively used ChatGPT or Claude or Perplexity or Grok, and you know, if you ask questions about the industry you've worked in, as soon as you scratch the surface and go a bit deeper, you start to realize that, oh, okay, these answers are plausible, but it doesn't really know what it's talking about. And even with deep research, which is some amazing advancements in terms of bringing internet search into the answers, the actual knowledge of the LLM and vision model itself is not deep enough in terms of the specific industry understanding and real world understanding. I know one of your previous speakers talked a lot about how the models are not world simulators. They don't understand physical cause and effect. And for me, in aviation, that manifests itself with the models not understanding you can only have one aircraft at a gate at any one time. So quite an important issue for those kinds of planning and reasoning. So a big problem, a big gap, get over the hurdle, and there are hidden risks as well.